In this video, we're going to talk about some of the ways that scientists describe matter. To begin, let's talk about what matter is again. Matter is anything that takes up space and has mass. Mass is the measure of the amount of stuff there is, so matter has to have has to take up space and have some amount of stuff. Now, we use properties to distinguish between materials and classify them. Properties is a fancy way of saying characteristics. We measure properties, we observe them, and we use it to help us identify what things are and categorize things. And there's two sets of types of properties: intensive or extensive, and physical or chemical. Let's talk about intensive and extensive first. Intensive properties depends on the type of matter you have, but not the amount. So melting point, absorbency, these and density, these are all intensive. The melting point of ice is 0 degrees Celsius. It doesn't matter if you have 1 gram or 100 grams, it doesn't change. Compare that to extensive ones, they do depend on the amount of stuff there is, the amount of matter. Volume, mass, surface area. If I have only 1 gram of water, its volume is going to be fairly low. But I compare that to 100 grams of water, it's going to be higher. So it changes with the amount of matter there is. That's intensive and extensive. Now let's look at physical and chemical. Let's first talk about physical. Physical characteristics can be changed without changing its composition. So you're describing how it is, not what it is. So, for example, volume. I'm describing how much space it takes up. Other ones other properties that are physical include color, size, state, or conductivity. One main physical property we're going to look at is density. Density is a ratio of mass to volume. It is an intensive physical property of matter. It doesn't matter how much stuff there is, the density is always the same. And it helps describe how the matter is. Density is a calculated property, and we calculate it by doing mass divided by volume, or D equals M over V. A quick and easy way to remember this: density is equal to a heart with a line through it. If you look, you've got an M on the top for mass and V on the bottom for density. D equals M over V. An easy way to remember the relationship of all three of these properties, mass, density, and volume, is this density pyramid that I have here. By covering up the one you want, you can figure out what they all are. So, for example, if I want to know what density is, I cover up density, and I have M over V, and that means I divide mass by volume. And if I wanted to find instead volume, cover that up, I have M over D, mass divided by density. And lastly, if I wanted to find mass, I cover that one up, and I have D next to V, meaning since they're next to each other, I'm going to multiply those variables, density times volume. So we have a couple different types of units that we use for density. We have G ml, G slash cm cubed, or kg slash L. Grams per milliliter, grams per centimeter cubed, or kilograms per liter. We will be using these two primarily in this class. This kilograms per milliliter is used for larger amounts. Let's do an example problem. We've got a 10 centimeter cube piece of lead has a mass of 14 grams. What is the density of lead? Well, I'm going to look at my lovely density pyramid here, and I want to find density. So I'm going to cover up the density, and it shows me that density is equal to M over V, mass divided by volume. So I'm going to find my mass. It tells me the mass here. I'm looking for grams to tell me mass, and it says it's 114 grams. And I'm going to look for volume. It doesn't say the word volume in the problem, so I'm going to look for either milliliters or centimeters or something like that. And it shows me that here, that's going to be my volume, so I'm going to have 10 centimeters cubed on the bottom. So I'm going to take 114 and divide it by 10, and I get 11.4. And since neither one of my units is canceled out, I'm left with grams over centimeter cubed, and there's my answer. Let's try another problem where it's giving us the density, but it's asking us to solve for another one. In this problem, we have if copper has a density of 8.96 grams per centimeter cubed, what would be the mass of a cube of copper with a volume of 125 centimeters cubed? So I'm going to look at my lovely density triangle. And in this case, it's asking me to find what would be the mass. So I want the M. I'm going to cover up the M. So M is equal to density next to volume, or D times V. So I'm going to have my density. It tells me the density is 8.96. 8.96 grams over centimeters cubed. The centimeters cubed can go on the bottom because it's being slashed. And I'm going to multiply that by my volume. It tells me the volume is 125 centimeters cubed. So 125 centimeters cubed. And you'll notice I have centimeters cubed on the bottom here, and that cancels the one on the top here. So I'm going to do 8.96 multiplied by 125. And when I do that, I get 1120, and I'm left with grams. So my mass is 1120 grams. Now let's talk about chemical properties. Chemical properties are characteristics that we use to describe the way a substance may change to form other substances. So, for example, sugar fermenting. When sugar ferments, it changes into a different substance. Burning, oxygen burning. Not just oxygen, but anything burning is a chemical. The ability that oxygen burns and anything having the ability to burn is a chemical property. And then the fact that iron rusts, that's a chemical property. We will stop here, and in the next video, we'll talk about changes that can occur.